And thank you to Dr. Tim Parkin. Our next panel is the presentation on track surfaces and maintenance reporting. This discussion will be led by Dr. Mick Peterson.
So I'm going to go ahead and kind of set the table for the rest of the discussion, and then I'll turn it over to the experts to tell you what they've been seeing. Jamie, at the end, is the superintendent at Churchill Downs. Chris is the assistant superintendent at Churchill Downs, but both of them have extensive experience at other tracks, Oaklawn, and I think a decade in Maryland for Jamie. And Chris used to...
23 years in Maryland.
23? Okay, all right. And Chris was at Maryland Jockey Club and then was the superintendent at Ellis. He was the superintendent. And Branden Brookfield is currently the racetrack testing director for Racing Surfaces Testing Laboratory, but he was also at Keeneland and did the daily measurements there. Let's see. So the maintenance quality system was put together and really was an outgrowth of the second Welfare and Safety Summit that occurred. And that was also when Racing Surfaces Testing Laboratory was created. Like the EID, this is an outgrowth of this event. There's 3 stages in the maintenance quality system. There's documenting the track design. There's pre-meet inspection that Branden does almost all of them. And then there's daily monitoring that's responsibility of the tracks. This then led to the accreditation, and the research that led into this was the Code of Standards, and the rewrite in 2020 of the Code of Standards for NTRA Safety and Integrity Alliance was based on the maintenance quality system for the track surface portion. This was then adopted as the HISA rules. So there's the origins of the HISA regulations on tracks are in this event. So standard measurements allow comparisons over time and between racetracks. This was a game changer when we went to the Horse Racing Integrity and Safety Authority, because instead of just this relatively small number of accredited racetracks, all the racetracks were participating. So at this point, though, we still have to work with the hypothesis that consistent surfaces are safer and make training easier. At the very least, it allows the superintendent to provide a surface that a trainer then can see the improvements of the horse and the development of the horse and the preparation for racing. Phase 1 of the design documentation and setup for the maintenance quality system consists of documenting the equipment in a standard operating procedure, setting target composition for the track. This is beyond sand, silt, and clay. This is also performance measurements that are done with the material from the surface, the geometry of the track, the banking, crossfall, and finally, a weather station is installed at a lot of the racetracks. Almost all the previously accredited racetracks, and increasingly there's this separate weather station at the racetracks. We use a hyper-local service for the rest of them. So this allows us to compare from year to year and to other regional tracks. So an example of this is consistent grading. If we have the track design documentation, these transitions from the turn into the straight can then be designed, and that material is then available for the superintendent and for training, but it's also available for the pre-meet inspection. And one of the critical parts of this is that there needs to be a consistent method that's used for all of the measurements. So again, our hypothesis, tracks with consistent grades are safer, and consistent measurements then are needed to test this hypothesis. Phase 2 of the MQS is a pre-race or seasonal test that includes biomechanical surface testing, ground penetrating radar, testing of the composition and the performance of the material, and then check the grades with the laser level. This is possible because in 2020, the Jockey Club provided funding to allow us to pre-position equipment around the country so that this pre-meet inspection could be done everywhere from Emerald Downs to Gulfstream, New York to Del Mar. An example of this is consistent cushioning that results from the hard pan. As the hoof penetrates down in, it's decelerated by the top layer of the harrowed surface. The OBST, the biomechanical surface testing, measures the load on that forelimb. Ground penetrating radar then can detect that hard pan that the toe will contact during breakover is consistent at a consistent depth in the surface. If you have well-developed layers, like you see right there, that toe will penetrate down into that top line, and you can see underneath the base that's further down. Less consistent layers, or a varying depth of material, like you see in the lower image, is would tend to give a variable traveling variable load on the limb. So our hypothesis here is tracks with a consistent hard pan are safer. Standardized measurements, the ground penetrating radar that you see the images of on the right-hand side, then allow the standardized measurements to be compared between different tracks. And even better, if we see a less developed hard pan, typically we try to help the superintendent get it established prior to leaving. Phase 3 is probably the hardest. It's the daily tracking and measurements. You have logging of every piece of equipment that goes out on the track, cushion depth measurements are made, and the moisture measurements are made on both the dirt and the turf surfaces. Consistent moisture, cushion depth, and turf condition require standardized measurements to test the hypothesis. So the most basic tools for testing this is just a moisture meter and a ruler. You can look at the cushion depth and moisture and then manually enter it through the maintenance quality system database interface. That requires then handwriting it, typing it in, and going back to the office. Turf track also then requires separate tools. We're basing our current methods on the best practice, again, that came out of research that was done in New Zealand, and then moisture. Here's an example of moisture measurements on turf. Some areas are required to use reclaimed water, which increases soil salinity. The most common method of moisture measurement is impacted by salinity, and you can see there the difference between the moisture measurements based on the salinity. There's a huge impact. So again, having consistent measurement methods requires that we be able to correct for this salinity and work with the racetrack superintendents to have equipment available for them. That's the integrated racetrack surface tester that we've developed and put in the public domain. It's a penetrometer and a moisture meter. It can be used on dirt and synthetic surfaces and replaces the manual measurement with one device. Then it adds temperature for synthetic tracks. It provides salinity corrected moisture measurement, and the penetrometer correlates to injury on turf, which we know from the New Zealand research. The biggest thing is it's consistent between users, the methods. Data sharing between tracks is probably the biggest thing that's come out of this. That would include the documentation, pre-meet, and daily testing. Our hypothesis is consistent surfaces are safer and make training easier. If we pool the data, that provides for daily decision making at the tracks, but then combine the surface data with other data, we have the EID data and the HISA tracks going to HISA. The long-term goal here is to begin to pull things together in a way where the track data can be built into the models, very much like what Dr. Parkin was talking about. So I want to pass this off to the panel now and ask them how they are able to use some of this data on a daily basis. The first stage of the data is the documentation of normal maintenance. It used to be called the maintenance manual, now it's standard operating procedures. You were both at accredited tracks. What has changed or hasn't changed, and who does the SOPs at Churchill, for example? Or
So we did have standard operating procedures, even under the NTRA, who used to do they regulated somewhat prior to HISA. So the standard operating procedure obviously is always in somewhat, it's been changed over time. We've actually changed the equipment at Churchill significantly in my tenure there. So, we've updated the standard operating procedure, but there was a SOP prior to my arrival there.
Chris, how about Ellis? Is probably a smaller operation with and so.
Yeah, so Ellis, I was lucky that I didn't really have to write a SOP at Ellis. I was lucky that, our director of racing would write it, but we would communicate with each other to make sure that, with updated equipment, we made sure that was in there, different things, different maintenance practices that we're doing to the track. We had a lot of communication with each other to make sure that once she was writing it and establishing it, that it was correct and up to date, and
Branden, you go to all the different tracks, and the tracks, a lot of them weren't accredited. You want to talk a little bit about the maintenance manual?
Yeah, certainly. So the maintenance manual it's also a part of the on-site testing that I do. So as I'm coming to these different tracks, usually 1 to 2 weeks before the race meet starts, I'm trying to build this manual. So the way I like to think of it is a Lego set, right? If you had the same pieces, the same parts, I want anybody reading that to be able to end up with the same setup. So I'm looking at things like how far are the teeth set away from the frame. I'm looking at tire size, tire pressure on tractors, even hitch height in some of them. Specifically, that was something we had to look at with Keeneland. We had 2 different types of tractors that we got from John Deere, and they had a different hitch height. It caused the harrows to set at a different height. And so all of those things are parts that I'm trying to incorporate into that maintenance manual, so that if you do get a new harrow, if you get a new tractor, if you have a satellite property that ends up with the same equipment or even slightly different equipment, you're able to really refine what you're doing and end up with a consistent outcome no matter where you are.
And it's funny you say that. We have 4 harrows we run at Churchill, and one particular harrow, if it's not hooked to the same tractor every day, so we actually just number them, tractor 1, harrow 1, they all match up, and because one particular harrow, if it's not hooked to the one tractor, if it's hooked to another tractor, it doesn't act right, and it's odd, but it's fine it's the number 2 harrow, number 2 tractor.
That's funny. So every track is, according to the HISA regulations, is supposed to provide basic geometry for their surface as a part of HISA regulations. Jamie, when you have moved between tracks, when you went to Oaklawn, or was this sort of information available to you when you?
What's that?
Design information, like banking and crossfall.
So I'm a little older than these 2 guys here sitting next to me. I started at Pimlico in 1986, so 40 years ago last month. There was very little design. I'm sure there was design work, but things have evolved hugely in the last 40 years. I've seen Laurel rebuilt twice in my tenure at the Maryland Jockey Club. And so now we do have, yes, much better plans. Everything's documented. I mean, you have the grades, everything's been surveyed extensively. But when I started, those things weren't available. Yes, we did have them at Oaklawn. I've got them at Churchill. And then when we did all the work we did this past winter, we actually did an extensive job at Churchill, and we took it down to the base and had everything surveyed. Roderick came in, we flew a drone around, and it's kind of neat how they survey things now, and they do it right from a drone. And the specific, I mean, it just right down to, fraction, I mean, within 1/100 of an inch. I mean, it's amazing what they do with a drone. And so we have everything updated at Churchill now, and, you know, it's incredible, you know, to think what we were working with 40 years ago.
Chris, you've moved a number of times. I mean, starting out at Timonium, actually.
Yeah. So Timonium's a small little 5/8 bull ring track. When I started, I was 16 when I started. We still ran 10 days then they dropped it down to 7. So when I got into grading and peeling the cushion off of the track and looking at the base and doing repairs and things like that, small track, small budget, I mean, we had nothing basically. You know, I was lucky that who I was learning from, Jamie, spent some times there, some years there. They knew the track, but I didn't have anything to go off of. You know, moving to Laurel and Pimlico again, you know, didn't have much, but I was lucky to, if I had questions or concerns, I could call Mick, I could call Jamie, who's, you know, spent a long time there. So when we rebuilt Laurel, we did have come in and shoot grades, cross slopes with the help of Mick and, you know, our contractor at the time. So we're able to get some things on paper and have that. When I moved to Ellis, we had nothing. I came into that totally blind. I had no idea what the cross slopes were, what they were supposed to be, the radiuses. I mean, Ellis had no information. So my 2 years there was really trying to build a program of what we're doing, what we're adding to the track, what we're going to do. Let's find out what the cross slopes are, and then what they should be. Let's work on that, on our radiuses and things like that. And, you know, now, you know, coming to Churchill and working with Jamie and, you know, being a part of pulling the track back and shooting grades and inspecting the base, you know, it's having that information now to be able to work with and have for a long time is huge.
Branden, what do you use that information on in your pre-meet inspections?
So for the pre-meet inspections, there's a couple things. One, I'm looking at it on ground penetrating radar, and then the cross slope measurements. So the cross slope measurements is going to give me the upper level of the surface. That we're typically somewhere around 2% in the straights, typically somewhere around 4% in the turns on average. The biggest thing that I then see from radar is whether or not our upper level of the surface matches our base. So all the bases had a specific grade when they were put in at the time of the track's construction. And if your upper level of the surface does not match your lower level, I'll either see the surface thinning out as we get to the inside rail, or I'll see it getting really deep as I get towards the outside rail. Both of those obviously impact the consistencies and the ability of these guys to do their job like they said, at some of these places, you really don't know what you're getting into. I've seen places where they have the schematics of the track pasted on a wall and it's taller than I am, and you can go through it line by line and be really on top of it. I've also seen guys get a 3x5 note card when it turns over of this is what the other guy was doing. The disparity between those two is what we're trying to close at this time, to make sure that guys that are taking over as people come in and out of different properties, seasonal meets, that they have everything they need. And so those are all things I'm trying to keep in mind as I'm on site for the pre-meet testing.
Well, and I think one of the big challenges is the transition from the turn into the straights.
Yeah, certainly, and especially defining where the turn actually starts. So on the one that you saw earlier in Dr. Peterson's PowerPoint, that is assuming the turn starts about 100 yards before the actual curvature begins. And so that is the incremental change of the grade. And so if I'm going from 2% to 4%, we don't want to do that all at once. We want it to be gradual so that the horse doesn't have this massive change that he has to deal with under speed. So it's gradual. If they don't have these track documentations, I've seen guys where they're quite literally looking down the rail and it's the first post that's out of line is where they're determining that that turn starts. And so, again, it becomes really important to have these designs out to understand where your track should be. If you don't have them, you open yourself up to variation just from not knowing, and we're getting to a point where that's just no longer acceptable.
So every meet, or seasonally for some tracks that run essentially year-round, the composition is tested. Test results are provided to the track as a part of a report, as well as historical data for your track and usually comparison tracks, especially if there's a fairly clear circuit that they're running on. Have you ever found something surprising when you looked at one of those reports, or something unexpected?
I don't know if I found it surprising. I mean, I think it just, if we see the track getting sandier and losing the fines, you probably know it. You just need to, you don't want to add too much silt and clay and get too rich. So I think those results help you, figure out, you have to do a mathematical calculation on how many tons of silt and clay you want to add to then bring the material back up. We're always, especially in a rainy climate, you're losing your silts and clays through, runoff in the, when the water runs off the track, it'll generally carry the silts and clays off first. So we're always trying to replenish them and stay in that range. I don't know that I've ever been surprised necessarily. You kind of have a gut like, this thing's getting sandy, or, if you put too much silt and clay in there and get it too rich, you don't want it to get hard, so then you're putting sand on it to dilute that. So I don't know that I've ever been surprised, but it's just a tool that, just keeps us aware of what we've got.
Chris, thoughts?
Mick and Maryland, we tested a lot with running during all 4 seasons, never really getting a break. We had to make changes to the track really on the fly, basically. We never really stopped for training. So I wouldn't say I was surprised or taken back, but, maybe sometimes during going from winter to spring, depending on the type of winter we had, we could have lost a lot more fines quicker than anticipated, or, maybe we didn't. It was that seasonal adjustment that, just because we added, 1,000 tons or so of material coming out of winter into spring, it doesn't necessarily mean we're going to need to do that next year. So, maybe the volume of year to year, depending on the weather conditions, might shock you a little bit, but with the amount of testing we had, I felt like we tried to stay on top of it the best we could, so we weren't surprised or we weren't shocked.
Branden, do you ever notice things that you say, I'm going to have to get an extra sample, or?
Yeah, certainly. So, and a little bit different situation than what these guys are in. A lot of the ones that I see that is the seasonal meets. So, especially somewhere where they've completely come away from the property for an extended period of time. So, if we have a place that, well, you can take Aqueduct, for example, before the renovations at Belmont. They would run through the winter into the early spring. They would take off as they went back to Belmont and Saratoga. In the fall, we had to make sure that the track had held up from those New York rainstorms and the weather that you get being right there on the coast. So we would certainly take a look at that. There's places that I had come back maybe a little bit different in my testing, that I would grab an extra sample from the inside rail, extra sample coming out of the chute, some of those areas that are just a little bit different, and make sure that the composition there was consistent or wasn't a contributing factor to what I was seeing in my tests.
So biomechanical surface testing is also done as a part of the pre-meet inspection. Do you use that information, Jamie?
Yes, definitely. The hoof tester, everything, ground penetrating radar, and then the soil results. We look at everything, the grades, want to check ourselves. So yeah, no, I look at everything very closely.
Chris, you and Caleb did quite an exercise at Laurel at one point. Do you want to talk about that?
Yeah. So when we rebuilt Laurel Park, we were changing equipment, changing the surface composition a little bit. So we're trying to figure out, okay, if we're happy with our soil composition, we want to go to different equipment, what's going to do the best job? And Caleb was great. Caleb was out there, for weeks at a time almost. And we would I always called them practice laps. So we would take different equipment out, work the track. Caleb would come out and test it, and we could be able to get live results there of, you know, this is what our composition looks like, whether we're, you know, cutting or harrowing at 3 inches or 3.5 or 2 3/4. And we can get real life data with every test to try to hit our target goal. We didn't want to change the footing too much, the results, meaning when we changed the composition, but we knew that it was going to be different. And with different equipment, if we can get more consistent and better results, then we'd be fools not to go with that. But the only way you're going to get that before you can send horses out there is you need to do your testing. And we had a whole bunch of different harrows, drag harrows, hydraulic position controlled harrows, floats with back rakes. We were able to work the surface, reset it after every time, go through different moisture compositions as well with that equipment and get real life, you know, real in-time results to make the best, you know, hopefully the best decision for the surfaces and for the horses.
Branden, when you see variability, especially the tracks that are newer to this, if you see variability in some of the measurements, what do you typically do with that information, or how do you help?
Yeah, so it really depends on where I see the variability. So the biomechanical surface testing, we're looking at 3 parameters. We're looking at cushioning, which is the vertical. We're looking at slide, which is horizontal, and we're looking at impact firmness, which is deceleration of the hoof. So between those 3 things, when I see variability, there's different things I'm looking for. So if I see cushioning, that vertical loading change, with slide as well, the 2 loading parameters that we see. If I see a change in those, the first thing I'm trying to do is establish the area. Obviously, the harrows, the floats, the water trucks, these are all covering 12 to 20 feet of area each time that they go by. So typically this is not a localized thing. It can go on for maybe a couple hundred feet, 1/16 of a mile. It's, you know, something that was set up. Weirdly enough, it might even be that entire lap. And so I'm looking for that. Example of where it might be more localized is washouts. If we have an area where the track kind of washes away, that I will typically see pretty localized. It's a little bit easier to talk about. It's just a specific spot. But trying to identify that area so that when I go back and talk to these guys, it's not, you know, it's weird somewhere over there. It's you're weird from your 16th pole to within 100 feet of your wire. That's an area that I'm going to take a look at with the grades. I'm going to take a look at it with the ground penetrating radar. We're going to try and figure out why that came back so weird in my loading so that we can address it. Like I said, typically I'm there certainly before racing starts, but also most times before horses are even on the property, so that we're able to get these things addressed and not have them be lingering issues throughout a meet.
Ground penetrating radar is used to assess the base of the racetrack and understand if there's a consistent cushion. Churchill just did a careful remixing of the track. Was ground penetrating radar used, and did it help in any ways?
Oh, yes, no, definitely. When we took all the cushion off and had it down to the base at Churchill, Branden came in, and along with the surveying that we did with the drone, Branden came in with the ground penetrating radar and checked the base. And I know you were involved with this, Mick. It was prior to my time at Churchill, but they had a sinkhole in the half-mile pole area. And Butch Lear was there then, and he fixed that spot and had you come in and run ground penetrating radar. And it's funny because and so having not been there, I checked from the 7/16 pole to the 5/8 pole. It was somewhere between there, wasn't it?
Yep.
And again, I wasn't there, so I don't know exactly, but I looked thoroughly and could not find it, and I don't think we saw any issues. But I mean, yeah, I mean, we did the ground penetrating radar for things like that, and saw nothing. So that, I mean, yes, it was nice to. Didn't see anything visually, but then the ground penetrating radar supported that we didn't see any, you know, any abnormalities, you know, in the heart and in the base.
What's the most common thing that you see in the pre-meet inspection on the ground penetrating radar?
So depending on how long the track's been in, it does change a little bit. I would say typically the biggest thing I'm seeing is the establishment of that cushion and hard pad layer, specifically where they're meeting. A track that has so you saw the ground penetrating radar images earlier. We'll get a really clean reflection when something's really established. And what that does is when you have a place like a Keeneland or a Churchill, Santa Anita, Naira that has large volumes of horse traffic every morning, you're talking 1,000 plus head training at each of these facilities. When you have that hard pan really established, it lasts throughout the morning. You don't have horses going over it so much that they blow that layer out of there. And two, it allows these guys to then really quickly repair it. They stay in front of that usage. And so every day that they're able to reestablish this, make sure that layer stays right where we want it to be and really just doesn't deteriorate. At some of the smaller facilities, that's probably the number one thing I see is they either haven't been allotted the time to come in prior to the meet or just haven't gone around the track enough, and you see just a weaker layer there that isn't going to hold up once they start racing. The other thing I see, especially at some of these places that are a little bit newer, the racetracks went in 70s, 80s, 90s, is some wear and tear on the base as we've gone, especially places that have to run through the winter, which I know both of you guys have experienced winter racing, and that can be really hard on a track when you're having to be out there 24 hours a day to make sure that it doesn't freeze into just one solid chunk of dirt. So those are probably the two things that I see the most.
HISA requires 8 locations for moisture measurements. How many do you do at Churchill on the 2 surfaces?
So right now we're doing every 8th pole. We do 3 points across through the race lanes. So we're, doing 24. Let's see, why do I think it's more than that? Are we doing every 16? What do the guys do?
For race days this year, we were doing every 8th pole. When we were just training leading up to the meet, we were doing every pole, every 16th pole.
Every 16th pole, okay.
So if, now that our race meet is over with, we do have a little bit more time. We're not in a rush. No one's scrambling to get ready for a race or get the turf ready. We have a little bit more time. So, that's
Yeah,
a
so when we're
possibility.
racing, track closes for training at 10. First race, post time is at 12:45. So and with that time to get the track ready, yes, we cut back to every 8th pole. But when we're not racing, yes, we will do it. We'll do more, especially leading up before the race meet. The more information we can get, the better.
So you get the report almost immediately on your phone
Yes.
from that. Have you ever found anything that surprised you?
I recently, actually, the turf had a little bit deeper penetration than I thought, but I went out and looked, and everything was good. And so you can pull up every individual. It gives you an average, which I generally look at the average every day. But then if the average, then I'll go back. If something looks funny in the average, I will go back and look at all the individual points. And occasionally on the turf, he might have hit a divot where, and we're filling we just ran 108 turf races at Churchill this spring, and so we had quite a bit of fill in there for divot fill. You might have hit a spot like that.
Chris, any surprises you've had?
No, same thing last year of Ellis, same thing with using the penetrometer, which, I can speak for myself and the guys I've worked with and guys I work now. We love it because, like you said, we can get those results instantly. So if something looks a little off one day, like Jamie said, we can pull up an individual point. There might be one section where, we got much deeper penetration there. Let's go back out and double check. Normally it's, we might have took a reading in a divot or something like that, but without getting that information immediately, you would have never known. You just would have thought, we're just a little looser today for some reason,
And
We
so
can go back and double check.
So the good thing is with that too, it's also GPS, so you know exactly where that point was taken.
So did you measure cushion depth regularly before you had the IRST, or is that relatively new?
So we used to, even back in Maryland 30 years ago, we were doing depth charts. We actually used to post it for the public, and we would just go out, basically with a ruler and do depth charts around the track. So yes, we've done, cushion charts for a long time, kept track of that.
So that's like New York. I didn't realize Maryland did that too, the depth charts for the public.
Oh, yes, yes. Well, I don't know if they still are. A long time so I've been gone from Maryland for 18 years, but we used to do depth charts, yes.
Have you ever measured the main track with the IRST when it's floated?
Yes, we do it every day. And so, it's interesting. I think you and I have talked about this. Sometimes actually, it's amazing how very close in moisture. If you have a good seal on the racetrack, the moisture doesn't seem to be more significant, even if it's sloppy, because the water's all up in the surface, but it gives you the penetration depth, and then it takes the moisture reading there and down a little bit. It's, if you have a good seal on the racetrack, your moisture is not significantly, if you keep your moisture all up on the surface on a good floated sealed track, the moisture is not significantly different when, down into the surface.
Yeah, I think there's a lot of people who don't understand that a properly sealed racetrack, the water's on the top, it's just going downhill, and that's one of the reasons grading so critical. What were the protocols at Keeneland when you were there measurement?
So when I was at Keeneland, we were pretty similar. We were every 16th pole. And we were, at that time, we didn't quite have the IRST yet, so we were using the ruler for cushion. We were using the TDR for moisture on both the turf and the dirt, and then we were using the going stick at that time on the turf, and we were doing every 16th pole there as well. And again, and our rule of thumb was any day a horse touched the surface. So if we were going to do turf works, we were out there. If they were obviously race days, and so that was kind of our rule of thumb, was any day a horse touched that surface, we made sure that we got measurements prior to that to ensure that we didn't pick anything up.
Jamie, I'll let you take this one first. What do you see as the next steps? We've got these measurements, we've got some tools in place, we've got the pre-meet inspections, but where should we go next?
Well, I think we need real-time moisture sensing. As you and I, we've talked about it. You've been working with Glenn Kozak at NYRA on moisture sensors on the harrow teeth. And I know that's, it's not as easy as it sounds, as you well know, but that's where we need to keep, whatever moisture readings you take in the morning, they're constantly changing. You've got evaporation, you're adding water with water trucks if Mother Nature's not doing it. So your moisture levels are constantly changing, and you're trying to maintain consistency there. So I think that's the biggest thing. If we can ever get the harrows to, have moisture sensors on them, so that we basically are taking readings between every race.
Chris, I'll give you a little different question, going all the way back to your Timonium experience. What would you see the next step, especially for the smaller tracks that may have fewer resources, both human as well as financial?
That's tough. It's, working at a smaller track with smaller budgets, it's tough, because Mick, you and I have talked about it. The guys that are running smaller budget tracks, they have to be really innovative to get all the proper data and just do your job. With, smaller crews and rising prices, the way the world is now, nothing's cheap, and everyone has a budget. But it's hard, you have to, I don't think that, if I was still at Timonium today and called you up for a penetrometer, they might push back on that a little bit, but track guys, we need, things like the penetrometer and the TDR and taking daily measurements. They're tools that need to be in our tool bag. And, us track guys, we need that to make sure that we are giving a consistent and safe surface, every single day. Because it doesn't matter if it's raining 3 inches today and 90 degrees tomorrow, the track needs to be right. And that's, it's tough. And, I don't have the right answer for what we should do or what can we do, other than, spend money, and, no one really wants to hear that. But
Well, as Branden said, a TDR and a roller are not a huge investment.
That kind of brings up the question, Branden, as somebody who's tested just about every racetrack in North America, does the lower budget necessarily correlate to worse outcomes?
Not necessarily, and I will say in the last 4 or so years of us doing this pre-meet testing at a really high level, the biggest thing I've seen is a lot of that ingenuity that Chris has talked about. We have, when you look at consistency from top to bottom, we have got places with 2 nickels to rub together that are in our top 5. They've tested their surface, they understand their surface, they know where their variability comes from, and they control those variables, and that gives them a very consistent outcome. And for some of these places, it's been it's not like they get a huge run up to this. If they had something they wanted to check on, they may call me on a Thursday afternoon and I'll be there Friday morning. So for a lot of these places, that consistency is also being upheld when nobody's watching. It's not just, oh, he's coming, let's get ready, we've got a 2-week run at this. We're seeing that consistency, especially as I test throughout some of these meets, being maintained. So while budget certainly can make things easier, with the manpower and the equipment and things, we have seen really consistent results at both ends of the spectrum.
Yeah, and I think I want to assure everybody too, one of our goals by having this large data set is making sure we understand which measurements matter. And as we're seeing so many of the tracks begin to improve, we're also seeing that some of these measurements may become less important in the future just because everybody's doing the same thing, and that's really the standard operating procedures and the Legos that Branden was talking about. You can walk in, there's a transition into superintendent, and things don't completely fall apart because they've got the information they need. Well, thank you very much for that. I think that's very helpful. Thank you.